We've run out of
I
time.
see Taha. Taha is ready. Yeah, let's get him on stage. Yeah, yes.
Yes, spotlight him. Okay, super. Hi, Taha, how are you? Sorry, Tala. How are you doing? You are on
We can't hear you yet. We can't hear you yet.
mute.
We can't hear you, Taha. Okay, Professor Trabelsi, you will come next. We can't hear you yet.
Okay, maybe let's do a quick mic check.
We can't hear you yet, Taha. I don't know why.
How about now? Is it now
Yeah,
working well?
yes, now it works.
Yeah, I think
Okay.
now it's better. Yes, yeah. So a lot of mutes here and there, so all the time.
Thank you so much for joining us at the roundtable. The floor is yours, but for those who are interested, what we are going to be discussing now is the African quantum startups and lessons from the front lines. Taha is the founder of iCafe, IBM, and an IBM Qiskit advocate, and we'll be sharing, I believe you have a few slides or a presentation prepared.
No, I didn't prepare a presentation. I just prepared like few points, and then they are put forward for discussion.
Fantastic.
So,
Please, the floor
yeah,
is yours.
Yeah, okay. Yeah, thanks. So I would like to start first from my background, where I did came from. And I'm currently co-founder and general manager of Molcat SAS. It is a startup, quantum AI startup based in Paris. And also Molcat as a startup is a proud member of QUIC network. It's a European network of quantum computing and technologies. And also QEDC, the equivalent one in the States. I'm also lecturer and researcher at Amsterdam University of Applied Sciences, and recently we have developed a new master that's accredited by 4 universities to prepare the future workforce for quantum tech, which is also the education is a relevant point here. And I'm also founder of iCafe, an online academy platform offering accelerated AI-powered high-tech learning courses. Recently, I'm also proud to say this, Politica Alexandrina and our team, we collaborated together to organize a successful quantum hackathon named as Alexandria Quantum Hackathon in quantum computing, with topics and the problems relevant to the ecosystem, but also Egypt as a country. It's also served as a regional hackathon because it also included teams from the Arab and African states as well. Of course, there was a support from IBM, and here Dr. Ahmed Younes was one of our prime speakers and also jury members, and we were honored to have him in the hackathon. And there is also members of our organizing team here from our excellent mentors. They are here, so maybe they can make noise if they can. So first, I would like to highlight a few things. What we need to start the quantum computing. I would like to draw this. I wanted to complete from and continue from the last states that and the statements that already my colleagues have already stated before. And those are about how to draw investment to Africa. And there is also nice experiment have been done in Malaysia, where the Malaysian experiment, it was successful experiment. They have already attracted a lot of factories from chip makers, semiconductor industries, and also high-tech regions to Malaysia. And some of them were very challenging to move or open abroad apart from United States. And the reason for that, they worked very hard in preparing those curriculum and those educational programs, and tailored them to the need of the market, not the whole market, but they have chosen a few points and a few problems where they can master and get expertise in. And by doing so, they can contribute to the global supply chain of this particular technology. And for the global supply chain here that they worked on was the semiconductor industry. They mastered, for example, the chip simulations, the processor simulations, the testing and benchmarking and the characterization of the processors. This is a very crucial step in order to make a perfect processor immune or prone to avoid the kind of problems and faults that you might have due to the fault or some systematic errors that might happen during the manufacturing process. So from this experiment, Malaysia could draw the foreign investment, but also could open millions of jobs in their ecosystem. Of course, a million a year is a big number. It was about an order of magnitude. That number allowed them to be one of the leading regions in the high-tech market. Similarly, if we project this in quantum, as also my previous colleagues have stated, we need to start from education. In Egypt, there is also strong education in quantum. There is also very nice initiatives that happen in Africa. But the main essence here is that we should focus on where to fit in the supply chain, what we can fit now, what could be fit in the future, and from the near future and the long-term future. Now, for example, we have, as also other colleagues have highlighted, and also Dr. Yunus in his slides, we had a few things related to the quantum software, the quantum hardware, the quantum communications. There is a lot of verticals in the industry. Each vertical requires certain skill set and a set of expertise. And the easiest way to get started is, for example, to start by software, preparing a good quantum software engineer who can program the quantum hardware and, of course, apply very useful use cases. It could vary also from one country to another, depending on this question, what we're trying to achieve, where the region is trying to fit in the global supply chain. If we learn the lesson from the Malaysian experiment, it would mean that finding out one or two points to master and get a mastery in, and using this mastery to prepare the workforce to attract the foreign investment that these engineers or this equipped and skilled workforce can work on this particular problem or a particular part of the global supply chain of this technology. One of them could be characteristics of the hardware, the simulation of the hardware, enhancing the errors that happen in the qubits. All of this could be done in the software side as a start. And as money comes in, you can jump in to the hardware part and jump to an extra step, which require much more money because operating the quantum hardware is very expensive. And nowadays, there is many types. We have about 9 to 11 types of quantum computing technologies, varying from superconducting qubits, neutral atoms, ion trapped. We have the photonic chips. We have also silicon-based quantum chips and topological qubits, which are not fully industrial realized yet. And there are many more. And for those type of technologies, to operate them, you need very expensive equipment. And this is why it comes at a higher timeline in the beginning. So we need to start first, if you wanted like to start in quantum, pick up the kind of expertise that you have, what kind of a skill force you need to complement in order to get ready, and the software and the algorithm development could be an obvious choice. And then from the return on investment, from the money, the labs could be started, and the more collaborations can start, and also work on several other arenas. There is one important question that has been asked all the time. Do I need a PhD to do this work? And the answer is no. You don't need to be an expert in the field to get a job in the quantum computing market. And this is very essential. What you need is actually to know that the major bulk of the job market in quantum computing and the quantum industries is not about being expert in the field. It's also related to the enabling technologies and the applications. So, for example, since you need to operate in cryogenics and this very cold, maybe extremely cold fridges to operate the quantum processors, you need people who understand electronical engineering, communication engineering, also to people who can wire things and enhance things and craft and even seal and have a very final product for the customer, and maintenance engineers and so on. There is many job requirements, and of course, plus the software. So you don't need a PhD to do so. If you have the good training for 1 or 2 years, you can jump in straight away to the market, pretending that already you have the skill set that will fit in this particular part of the supply chain that is suitable for the region. This is one thing. The second thing is to know that you don't need also to be a highly theoretician to start. The quantum software also involves a lot of steps like the packaging, enhancing the coding, enhancing the simulators. And there is also work, if you like, theory to work on reducing the qubits and so on. Having said that, if we all focus on a few points, okay, what we have as a skill force here, what is the major skill force we have? We have, of course, good software engineers, okay, that's good. Then they need quantum knowledge to be added. Do we have theoreticians? And the more some theoretical courses could be added as well to complement, and using this knowledge and leveraging them to attract the investment and the companies to tell them, okay, we have the ecosystem is ready, we have the workforce, we have everything. Please prepare and bring your offices here. And once they bring it, they see by their eye through hackathons, through events, through many activities, the kind of talents that already exist. And now the industry thrives for talents, so most likely that will be a good kickstart for the ecosystem. And now I'd like to hear also your thoughts and opinions about this.
Thank you so much, Taha. Gallery, you're open so far. It's been a bit quiet. It's been a bit quiet. So maybe if you would like to, I have a feeling you still have a few more talking points, so feel free. Oh, wait, hang on. They're coming in now. I think they were just waiting for the opportunity to ask. So Rossi's asked, what kind of legal issues concerning laws, regulations, and international codes have been encountered in this work with supply chains?
Okay, so that thanks for the question. I believe it came from
It came from Rossi.
From Rusty. Okay, thanks very much for the question. It's very nice indeed, and also it's very difficult one. There is no enough complete answer for this question, but I will try my best to highlight it. The first thing is about the IP, the intellectual property, and because now there is a race in quantum computing, and the only thing, okay, do you have the expertise to say I have my own IP, so you get a leverage in the discussion or not? So that's the first thing related to the legality. So usually companies, they try to, because it's a new technology, the race is open, the future is open as well. So they try to secure as much as they can from the intellectual property, which means that their own native products and also native innovations. And if you tell the company, I can also add to your IP, and I can contribute to that, then for sure that open a market at your place, because it means that you can contribute to this. So this is the first thing. And when they do work together, there is a lot of paperwork to be done on organizing the shared IP, the intellectual property, how it will be shared between the like involved parties. And the second thing, who will get which percentage of the IP in case this IP, for example, brought a nice revenue or a nice profit at the end. The second thing is collaboration between places. So there is also some difficulty in making collaboration. So usually collaboration happen if you really do very good job in attracting the companies, like what Malaysia has done. Malaysia already worked on preparing the workforce, so there is restrictions in the legality on what kind of technology could be worked out in those regions. However, by having the good talents and very well-equipped university programs, particularly for AI and for electronics, then that attracted the companies and make them surpass these legal issues to come to Malaysia and open companies like we have the Fox, Foxconn processor that famous company opened a branch in Malaysia. So this kind of legality also goes with what you can offer. So if you have less offering, the legality and the complexity of legality will become higher. If you have higher offering, you have a good negotiation bargain you can bargain about, and then you get a bit of advantage. And of course, all the time companies collaborate together. So it doesn't mean that there is complexity in legality. This stops collaboration. It's on the contrary. It means that companies need one another to develop the technology. So they work in consortium. You can find IBM collaborating with other companies as well, from software and from hardware. It's all everyone works together in the major markets. However, the legality comes, the challenge comes in if you have more to share, then the is on you, but then you need to separate which IP belongs to what will be the return on investment, how this work will be shared between companies and so forth. So I see a second question.
Yes, I think we've got like 1 minute left before we have 20 minutes left for the other two speakers. So maybe in the last minute before we take on another question, maybe if you could share, because essentially your journey just paints a picture of scientist to founder, essentially, and you've been in the front lines for quite some time. So maybe could you share a parting hack? Maybe that other scientists looking to switch into founder mode can use to turn their deep science into a viable product. So just like one closing piece of advice that you can share.
Yeah, thanks for this. It's very and indeed that's a very nice question. So I would like also to indicate that I'm also a YouTuber. So I have my YouTube channels both in Arabic and in English, and those I explain there some lessons about this. And one of the crucial lessons in this last minute is be good at something when you graduate from a university. When you do your research in a graduation project on the master or the bachelor level, or even at a PhD level, try all the time to focus on something applied. So you can have what is called a spin-off startup. It means that you spin off from your university, you get a license to use the research that you have worked on and turn into a product. Then you are creating your job when you graduate. So there is no need to wait. Oh yeah, now I have my degree and so on. This is all, when I was finishing my studies, I was focusing on that, part working in research. We have an excellent publications published everywhere. But then on another hand, we will look also for the companies for that, I would like to see, and this is also we can help with, because on iCafe we have also training programs, so some of them could be done for free indeed. And also in Molcat, we have some programs in quantum, is how to spend and how to train the graduates to learn about the research and learn about their competencies in order to spin off as a company. If 4 universities or 5 have done this, you will end up having 5 startups. Then you have 5 startups in quantum computing that leverage very small research, but the market needs them. Then suddenly that will also bring a collaboration. It means that it will draw the attention of the foreign markets. There is hubs here are working on that. So this is the first lesson that we'll try to see where is your mastery in. Get to your supervisor, work with them, and try to think how to make your research applied, how to convert it into an idea of a startup and spin off from your university. So you don't wait for your job, you actually create your job, not maybe you and your colleagues who are involved in the project when you just graduate. And if you need any help, just connect with me on LinkedIn. There is plenty of videos I can share you. And also we have our own symposiums and webinars that we do on this.
Amazing. Thank you so much for sharing, Dr. Taha. Please also share links to your YouTube channel. We'd love to see it. Please share them in the chat, as well as the link to your LinkedIn. If you haven't posted it already, please just post it now while it's still top of mind. Thank you so much for your presentation.
Yeah, thanks very much. And I would like to thank all of you for the kind invitation. And of course, all of the team here is very kind of you. And then hopefully we're looking forward for future collaboration as well.
Yeah, thank you so much. And if you could share in the chat if there are any internship opportunities, or how, you're also on board some of these people who are still in college who want to begin to learn to get into industry. So yeah, thank you for that.